Assalamu alaikum students. In today's lecture, we are going to start the next chapter, that is the fourth chapter, which is called gases, one of the state of the matter, and the topic which we will discuss today, that is KMT. Now, the main postulates of the chapter are the properties of gases, development of the kinetic molecular theory. Then we will come to know about that of the standard temperature pressure condition, that is STP. Different gas laws will be defined and explained. Then you will learn about that of the ideal gas equation and its derivation, pressure and its units derivation, different other gas laws, including that of the Graham's law of diffusion or that of the Dalton's law of partial pressure. And then you will find out that of the density or the molar mass from that of by the help of the general gas equation. Then you will learn about that of the liquefaction of gases, plasma state, the differentiation between the ideal and non-ideal or the real gases, different phenomena related to that of effusion and diffusion, that all will be discussed in this chapter. Now students, here the three states of matter are being given. You know very well there are three states of matter: solid, liquid and gas. In this chapter you will learn about also the plasma, which is considered as the fourth state of matter. It is going to give you, this slide is telling you about the order and that of the kinetic energy or the forces around about these particles, what the differentiation being here about these three phases. So here we have the solids with the more compact structures and that have no intermolecular the spaces between them. The forces of attraction are too strong, which keep them in a compact one structure, in a compact form, or they appear like that of have a definite shape, right, and have a definite volume. Then when we come to that of the liquids, the order is a little bit disturbed. There is a freedom of movement for the particles, so they don't have the fixed one shape, but they have the fixed one volume. Then it comes to that of the gases, which is the most disordered state, as the particles, due to their high kinetic energy, they can move apart from one place to another or from each other, right? So intermolecular forces in them are very weak, right? This is just an introduction that what the difference between these three states is. You know very well that the gases, they don't have the a fixed one volume or the fixed one shape, right? Now come to the next one. This is what about the gas, which we have to emphasize on, that they don't have a fixed one volume nor a shape, uniformly fills any container and they mixes completely with any other gas particles. Then they exert pressure on its surrounding. Last two will be discussed in detail in the next topics of the chapter. Now here, after the general intro, comes to that of the particular term, that is of gases, which is derived from a word chaos, means a random movement or chaotic movement. It is the property of the gas particles that they travel in straight lines, and when they travel in straight lines, they may collide with each other, which are the particles which are coming in their path, or they may collide with the wall of the container, right? In doing so, what they are doing, they are producing pressure, right? Pressure is the force per unit area that is generated by the force by which the particle is going to collide with each other or with the wall of the container. So that's why we say gases, they exert pressure. Similarly, the types of movement of particles when they are moving randomly and colliding with each other, it has a particular name. It is called Brownian movement, right? And it is the phenomena which was observed by Robert Brown in 1827, right? Gas particles, they can expand and they occupy all the space within the container. As I told you, they have the random movements and they have no attractive forces between them. So what will they do? If they get the freedom to move in a large one container, so they will occupy the whole volume. They will be a distance apart from each other, so long, right? So for a large distance you can say. So what we say, that the gases, they can expand, right? Gases are fluids like the other liquids. As you know, nitrogen is being converted into liquid nitrogen, and then it is applied further for the industrial purposes. Okay, then the particles in the gas liquid form, they can flow. Now the gases, they have low densities as there are large empty spaces. Particles, they are apart from each other, so the density is low, right? And the gases, they are easily compressible as they occupy the whole volume of the container. So what will happen if we will apply the pressure outside on that container? The gas particles, they will come close to each other as the space is going to reduce, so that the intermolecular forces will become prominent in them, right? And the occupation of the volume become less. So we will say that gases, they are compressed. Now here students, it's given the historical background of the kinetic molecular theory, which deals with the movement of the particles within the gas. A number of scientists worked for it, right? So some of them were the physicists, or some of them were the mathematicians who worked for it. One of the name is of Daniel Bernoulli, and he was a mathematician. He put forward the kinetic molecular theory of gases for the first time. Then the other names of the contributors are Clausius, who gave it its famous equation that is called kinetic equation, that is PV is equal to 1 upon 3 mnc bar square. Then there comes the James Maxwell and Boltzmann, who worked on the velocities of the gas particles, their distribution laws, and the energies of these gas particles, right, which are moving with the different velocities in the form of the groups, right? So this is a little contribution or the history for the formulation of the kinetic molecular theory of the gases, which was given by different scientists. Then there comes the main postulate. Now the main postulates of kinetic molecular theory are, look at this diagram first. Here the gas particles are present within this container. Suppose it as a container, and they are moving randomly, right? Now you can see the size of the particle, that is very small, right? So we say the first postulate is gases, they consist of very small particles which are called the atoms, or they may be ions, right? Or they are separated by each other by the large empty spaces between them, right? When they have large empty spaces and very small size, the attractive forces are negligible. No attractive, no repulsive forces will be present over there because they are apart from each other, right? So no attraction or no repulsion. Similarly, the volume of the particles is very small as compared to that of the empty space. Look inside this container. The size of the particle is very, very small, but the distance between one to another particle, they are very large. Means there is a vast empty space present within this container that is available to these particles to stay. Okay, now come to the next one. Here we have the particles motion. As I told you earlier, look in this container once again. The gas particles, they are moving in straight lines as the vectors they are going to indicate. And in doing so, what happens? They are moving towards each other, or they are moving towards the walls of container, right? So when they will collide with the what you say, with the wall of the container or with that of each other, so what will they do? They produce a collision. They will collide to each other, and in doing so, we say these collisions, they are elastic collision. Means one is losing while the other one is gaining, so net result is zero, right? So here we have that the collisions between these gas particles, they are elastic collisions. The next one is particles energy. Yes, when particles are moving within the gas particles as they are apart from each other, and they are of very small size, no attractive force between them, so they may possess a large amount of kinetic energy in them. Okay? Now here we have the diagram. You can see at the very low temperature the movement is slow, but at high temperature the movement of the particles become high, developing more pressure. Now it says that the gases, they can be compressed. The compression comes because the gas particles, they are apart from each other, large distances are present between them and the space is available to them. So what happens when you are going to apply the force from outside, it will make the particles to come closer, and what to say, compressed state will be formed for the gas particles, right, as the movement will become a little bit slow, right? So here the gases can be compressed, and in doing so may they exert the pressure within the container. Okay, now now here it is given the kinetic equation given by Clausius. Right, now before I go to this, two postulates are to be explained once again. That is the relationship between kinetic energy of the gas particles and the temperature. It is a direct relation. If temperature will be increased, kinetic energy of the particle will increase, giving it a greater movement, while if the temperature will be decreased, so the movement of the particles will be decreased, because the kinetic energy will become slow. Similarly, the particle of one type of the gas, they are same, right? But when you are going to compare them with another gas, then they are different from the other, right? Now come to the Clausius equation. It is also termed as the gas equation or kinetic gas equation, right? It is given as that PV is equal to 1 by 3 mnc bar square, which is derived with the help of that of the kinetic theory postulates, and it relates to that of the pressure of an ideal gas. Now, what the ideal gas is? Ideal gas is the gas which obeys all the gas laws at all conditions of temperature and pressure, right? And you know very well what the pressure is. Pressure is actually the force by which the particles of the gas in a closed container, they are colliding with each other and with the walls of the container, right? Now here the different one terms which are applied in it, they are T refers to pressure of the gas, volume by V, M for mass, N for number of moles, and C bar square tells you mean square velocities, which comes out as the sum of all the velocities of the number of groups of the particles which are present within the closed container when they are randomly moving within that container, right? Now this root mean square velocity, that is the that is given by C bar square, and it is equal to N1 C1 square plus N2 C2 square, then plus N3 C3 square, C3 square, and divided by N1 plus N2 plus N3. N represents the number of groups, number of moles of the particular type of the molecules of the gas particles, right? Which are moving with the different one velocities. We say a gas is enclosed in a container, so it is going to move randomly. It will go in any direction, so it can move upward, or it can move downward, or it can move laterally according to that of the Cartesian coordinate, that is x, y, and z directions, right? This is all about that of the Clausius equation, and then now comes to that. Now students, if you remember the postulates of the kinetic molecular theory, so you can well understand the motion of the particles of the gas. It is based on the kinetic energy. As you know that particles, they are of very small size of a gas, and they are moving randomly, they have large distances. Then the kinetic energy of the particles, that is the energy of movement, is related to that of the temperature. Increase in temperature will increase kinetic energy, movement will be increased, and if temperature is decreased, the movement of the particles will be decreased due to decrease in the kinetic energy. Now here the three types of the kinetic energies are considered: translational, rotational, and vibrational. Translational motion is the any motion which will occur in any direction, right? That is in a straight line movement, a random movement that is termed as the translational motion, which is related to that translational kinetic energy, right? That kinetic energy which will uh, give this molecule energy to move in any direction, that is the translational kinetic energy. The second one is rotational energy. In this rotational energy, consider that there is a center of gravity around which the particles they are rotating, right? So this will be termed as a rotational motion. And what about the vibrational motion? It is then when molecules they have the limited freedom to move, what will they do? They will just move to and fro, pendulum like movement. So it will comes out as the vibrational motion. Total kinetic energy is the sum of all the three energies: translational, rotational, and vibrational energies as it is mentioned. Right? So here it is given. These are the particles which are having different one movements in them. Consider this one first. The two of the particles they are moving upward along with the center which they have. This is translation movement, or they can also move downward, right? So this is what we say is translational movement. In the rotational movement, you can see around the central atom, the two of them they are moving clockwise or anti-clockwise. Okay, clockwise or anti-clockwise. They can move in this direction as well. Right जी? Now here in the vibrational there are two types. It is just like a spring. You say आप spring को थोड़ा सा stretch कर वो खुद ब खुद वापस आता है अपनी जगह की तरफ. Right? So there can be the symmetric stretching or there can be bending. Bending is that movement of the particles inward. Center जो है वो वहीं रहे लेकिन जो उसके जो arms हैं they move inward. That's termed as bending. Okay, so these are the different one movements which are shown here. This is all about today's lecture, right? So Allah Hafiz for today.